Hi students, application of derivatives, fifth video. Up to fourth video, in first two videos you know that the physical meaning of dy upon dx, the rate of change of y with respect to x and solving some problems. And third and fourth video, you know the increasing and decreasing functions. With the help of derivative, very easily prove that the functions is increasing functions or decreasing functions or neither increasing nor decreasing, or find the intervals the function is increasing and the function is decreasing. In this video, the third applications, we discuss the third applications, the equation of tangent and normal. And normal. Equation of tangent and normals to discuss the third applications. It means actually the geometrical meaning of derivative. The geometrical meaning of derivative we are using, that one is equation of tangent and normal. You know that y is equal to f of x be a real valued functions. ಇದೊಂದು ಕರ್ವ್ ಆಗಿದ್ದಾಗ this function is y is equal to f of x. Suppose here you can take P is a point x1 comma y1, point on a curve. At the point P you draw a tangent, PT is a tangent. PT is tangent. PT is tangent ಆಯಿತು. This tangent means it is a straight line passing through the point x1 comma y1. Suppose this line makes an angle theta to the positive direction of x-axis, then theta is called the inclination. So, and slope of the tangent, slope of tangent PT ಅಂತ ಹೇಳಿದಾಗ m ಅಂತ ಬರೀತೀವಿ, ಇದರ value is tan theta. Correct? Suppose m is the slope of a tangent PT. Then what is the equation of slope ಅಂದ್ರೆ ಏನು? Tan theta ಅಂತ ಆಯಿತು. ಅಂದರೆ this line with the slope m passing through the point x1 comma y1. Then equation of PT, tangent ಏನು ಬರುತ್ತಾಗ equation of tangent PT, point and slope forms y minus y1 is equal to m into x minus x1. ಇದು ನಮಗೆ ಗೊತ್ತಿದೆ. It's clear? y minus y1 is equal to m into x minus x1. ಇದು slope equation of tangent PT. PT is a tangent. This line tangent makes an angle theta to the positive direction of horizontal line ಅಂತ ಹೇಳಿದಾಗ tan theta is slope of tangent ಆಯಿತು. ಇದು ಲೈನು, ಈ ಲೈನ್ ಸ್ಲೋಪ್ m passing through the point x1 comma y1. Equation of tangent PT is y minus y1 is equal to m into x minus x1. At the point P, draw a line perpendicular to PT. ಹೀಗಿರುತ್ತೆ. Passing through the point P, perpendicular to, this one is PT. Passing through the point P, perpendicular to PT. ಇದನ್ನು ನಾವು normal ಅಂತ ಕರಿತೀವಿ. This one is said to be a normal. It's clear? Normal and tangents are both are the straight line perpendicular. Two lines are perpendicular means the product of the slope is equal to minus 1. Slope of the one line is equal to slope of reciprocal of the slope of other line with opposite sign. Slope of the PT is equal to reciprocal with opposite sign the slope of the normal. ಹಾಗಿದ್ರೆ ಸ್ಲೋಪ್ ಆಫ್ ನಾರ್ಮಲ್ ಏನು ಬರುತ್ತೆ? ಸ್ಲೋಪ್ ಆಫ್ ನಾರ್ಮಲ್ಲು ದ ಸ್ಲೋಪ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟ್ ಪಿ ಟಿ ಇದ್ದರೆ ಇದು ರೆಸಿಪ್ರೋಕಲ್ -1 ಡಿವೈಡೆಡ್ ಬೈ ಎಮ್ ಅಂತ ಬರಿತೀವಿ. ಗೊತ್ತಿದೆ ನಮಗೆ. ಟೂ ಲೈನ್ಸ್ ಆರ್ ಪ್ರಾಡಕ್ಟ್, ಇದ್ರ ಪ್ರಾಡಕ್ಟ್ ಮಾಡಿದಾಗ ಟೂ ಲೈನ್ಸ್ ಆರ್ ಪರ್ಪ್ಯಾಂಡಿಕ್ಯುಲರ್, ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ದ ಸ್ಲೋಪ್ ಈಸ್ ಈಕ್ವಲ್ ಟು -1 ಆಗಿರಬೇಕು. ಹಾಗಿದ್ರೆ ಇದರ ರೆಸಿಪ್ರೋಕಲ್ ವಿತ್ ಅಪೋಸಿಟ್ ಸೈನ್, ಇದು ಪ್ಲಸ್ ಇದ್ದರೆ ಮೈನಸ್ಸು, ಮೈನಸ್ ಇದ್ದರೆ ಪ್ಲಸ್ಸು. ಇಟ್ಸ್ ಕ್ಲಿಯರ್? ದೆನ್ ಈಕ್ವೇಷನ್ ಆಫ್ ನಾರ್ಮಲ್ ಏನು ಬರುತ್ತೆ ಆಗ? ಈಕ್ವೇಷನ್ ಆಫ್ ನಾರ್ಮಲ್ ಇದನ್ನು ಬೇಕಾದರೆ ಎನ್ ಅಂತ ಹೇಳಿದರೆ ಪಿ ಎನ್, ನಾರ್ಮಲ್ ಅಂತ ಹೇಳಿದರೆ ಪಿ ಎನ್ ಅಂತೀವಿ. ಸ್ಲೋಪ್ -1 ಬೈ ಎಮ್ಮು ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಪಾಯಿಂಟ್ x1 y1. ಅದೇನು ಬರುತ್ತೆ? ಸ್ಲೇಮ್ ಸೇಮ್ ಫಾರ್ಮು ಪಾಯಿಂಟ್ ಆ್ಯಂಡ್ ಸ್ಲೋಪ್ ಫಾರ್ಮ್ ಅಂತ ಹೇಳಿದರೆ y ಮೈನಸ್ y1 ಈಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ 1 ಡಿವೈಡೆಡ್ ಬೈ m ಇಂಟು x ಮೈನಸ್ x1. ಇದು ಇಕ್ವೇಷನ್ ಆಫ್ ನಾರ್ಮಲ್ಲು. ನಾವು ಜೊಮೆಟ್ರಿಕಲ್ ಆಗಿ ಹೇಳ್ತಾ ಇದ್ದೀವಿ. ಪಿ ಟಿ ಟ್ಯಾಂಜೆಂಟು ಸ್ಲೋಪ್ ಕಂಡುಹಿಡಿತೀವಿ, ಇಕ್ವೇಷನ್ಸ್ ಬರಿತೀವಿ, ನಾರ್ಮಲನ್ನು ಬರಿತೀವಿ, ಸ್ಲೋಪನ್ನು ಕಂಡುಹಿಡಿತೀವಿ, ಇಕ್ವೇಷನ್ಸನ್ನು ಬರಿತೀವಿ. ಇಲ್ಲೇ ಕಂಡೀಷನ್ಸು ನಮಗೆ ಗೊತ್ತು. ವಿತ್ ಸ್ಲೋಪ್ ಸಪೋಸ್ ಕರ್ವ್ ಹೀಗಿದೆ ಅಂದರೆ ಯು ಡ್ರಾ ಎ ಟ್ಯಾಂಜೆಂಟ್ ಪ್ಯಾರಲಲ್ ಟು ಎಕ್ಸ್ ಎಕ್ಸಸ್ ಆದರೆ ಸ್ಲೋಪ್ ಈಸ್ ಆಲ್ವೇಸ್ ಈಕ್ವಲ್ ಟು 0 ಆಗಿರುತ್ತೆ. ಇಟ್ಸ್ ಕ್ಲಿಯರ್. ಸಪೋಸ್ ದ ಕರ್ವ್ ಹೀಗಿದೆ, ನಾವು ಟ್ಯಾಂಜೆಂಟನ್ನು ಎಳೆದಾಗ ಟ್ಯಾಂಜೆಂಟ್ ಈಸ್ ಪರ್ಪ್ಯಾಂಡಿಕ್ಯುಲರ್ ಟು ಹಾರಿಜಾಂಟಲ್ ಲೈನ್ ಎಕ್ಸ್ ಎಕ್ಸಸ್ ಆರ್ ಪ್ಯಾರಲಲ್ ಟು ದ ವರ್ಟಿಕಲ್ ಲೈನ್ ಆದಾಗ ದ ಸ್ಲೋಪನ್ನು ನಾಟ್ ಡಿಫೈನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ದೆನ್ ಇಕ್ವೇಷನ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟ್ ಸ್ಲೋಪ್ ಈಸ್ ಇತ್ತಂದರೆ y ಮೈನಸ್ y1 ಈಕ್ವಲ್ ಟು 0 ಅಂದರೆ y ಈಸ್ ಈಕ್ವಲ್ ಟು y1 ಇಕ್ವೇಷನ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟ್ ಆಗಿರುತ್ತೆ. x ಈಕ್ವಲ್ ಟು x1 ಇಕ್ವೇಷನ್ ಆಫ್ ನಾರ್ಮಲ್ ಆಗಿರುತ್ತೆ. ಹಾಗೆ ನಾಟ್ ಡಿಫೈನ್ ಅಂದರೆ ಇದು ನಾಟ್ ಡಿಫೈನ್, m ಈಸ್ ನಾಟ್ ಡಿಫೈನ್ ಅಂದರೆ ಡಿನಾಮಿನೇಟರ್ 0, ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ಸ್ ಈಸ್ 0, x ಮೈನಸ್ x1 ಈಕ್ವಲ್ ಟು 0 ಆರ್ x ಈಕ್ವಲ್ ಟು x1 ಇಕ್ವೇಷನ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟು. ನಾರ್ಮಲ್ಲು y ಈಸ್ ಈಕ್ವಲ್ ಟು y1. ಇದು ಪರ್ಪ್ಯಾಂಡಿಕ್ಯುಲರ್ ಇದ್ದರೆ ನಾರ್ಮಲ್ಲು, ಇದು ನಾರ್ಮಲ್ಲು, ಇದು ಟ್ಯಾಂಜೆಂಟು. ಪಿ ಎನ್ ಅನ್ನೋದು ನಾರ್ಮಲ್ಲು. ಇದು ಕಂಡೀಷನ್ಸ್. ಹಾಗೆ ಜೊಮೆಟ್ರಿಕಲ್ ಆಗಿ ಇನ್ನೇನು ಹೇಳ್ತೀವಿ ನಾವು, ಸಪೋಸ್ ದ ಟೂ ಲೈನ್ಸ್ ಆರ್ ಟೂ ಕರ್ವ್ಸ್ ಆರ್ ಇಂಟರ್ಸೆಕ್ಟ್ ಆದರೆ y ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಆಫ್ ಎಕ್ಸ್, ಹಾಗೆ y ಈಸ್ ಈಕ್ವಲ್ ಟು ಜಿ ಆಫ್ ಎಕ್ಸ್. ದೀಸ್ ಟೂ ಆರ್ ದಿ ಟೂ ಕರ್ವ್ಸ್. These two curves intersecting, the point is P ಆಗಿರುತ್ತೆ. ನಾವು PT1 ಫಸ್ಟ್ ಟ್ಯಾಂಜೆಂಟ್ ಹೇಳ್ತೀವಿ, PT2 is ಸೆಕೆಂಡ್ ಟ್ಯಾಂಜೆಂಟ್ ಅಂತ ಹೇಳ್ಬೋದು. ಇದು ಆ್ಯಂಗಲ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಕರ್ವ್ಸ್ ಆರ್ ದ ಆ್ಯಂಗಲ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಲೈನ್ಸ್. ಟ್ಯಾಂಜೆಂಟ್ಸು is exactly angle between the two curves. Suppose this angle between these two curves is 90 degree ಇತ್ತಂದರೆ then you say that the two curves cut at right angle on the orthogonal curve or cut at right angles or perpendicularly. These are the two curves cut at right angles or orthogonal curve means angle between the two curve is 90 degree. It means these two tangents are perpendicular. The slope of the tangent of the first tangent and to slope of the second tangent is always equal to -1. This one is the geometrical. You know that slope of tangent, equation of tangent, slope of normal, equation of normal, the angle between the two curves. Suppose it is 90, the two curves are touch each other orthogonally or cut at right angles. ಇದನ್ನೆಲ್ಲ ನಾವು ಜಾಮೆಟ್ರಿಕಲ್ ಆಗಿ ಕಲ್ತಿದ್ದೀವಿ. ಅದನ್ನೇ ವಿತೌಟ್ ಡ್ರಾ ದಿ ಗ್ರಾಫ್ ಆರ್ ಕರ್ವ್ ಹಿಯರ್ ಫೈಂಡಿಂಗ್ ದ ಇಕ್ವೇಷನ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟ್. ನಾನು ಇಲ್ಲಿ ಹೇಳ್ತಾ ಇರೋದು ಒಂದು ಪಾಯಿಂಟ್ಗೆ, ಪ್ರತಿಯೊಂದು ಪಾಯಿಂಟ್ಸಲ್ಲೂ ಯು ಫೈಂಡ್ ದ ಇಕ್ವೇಷನ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟ್, ಇಕ್ವೇಷನ್ ಆಫ್ ನಾರ್ಮಲ್ ಇನ್ ಎವ್ರಿ ಪಾಯಿಂಟ್ಸ್. ಯಾವಾಗ ಸಪೋಸ್ ದಿಸ್ ಕರ್ವ್ ಈಸ್ ಕಂಟಿನ್ಯೂಸ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಡಿಫ್ರೆನ್ಸಿಯೇಬಲ್, ವೆರಿ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಸೇ ದ್ಯಾಟ್ ಇಕ್ವೇಷನ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟ್. ಯಾವುದೇ ಪಾಯಿಂಟ್ ಇನ್ ಈಚ್ ಪಾಯಿಂಟ್ ಯು ಡ್ರಾ ಇಕ್ವೇಷನ್ ಆಫ್ ಟ್ಯಾಂಜೆಂಟ್. ವಿತೌಟ್ ಡ್ರಾ ದಿ ಗ್ರಾಫ್ you have find the equation of tangent, equation of normal or slope of tangent, slope of normal using the derivative. That one is the geometrical meaning. It means what is the geometrical meaning of dy upon dx? Equation of tangent and normal means geometrical meaning of dy upon dx. Derivative of y with respect to x or f dash x. The geometrical meaning of dy upon dx. So, ಏನು ಹೇಳುತ್ತೆ? This one is y is equal to f of x is a real valued function. Suppose this function is continuous and differentiable. You say that this one is the curve like this. Y is equal to f of x, the given curve, continuous and it is differentiable. Suppose here you can taking P is the point to x1 comma y1. It's clear. PT is tangent. This tangent makes an angle theta to the positive direction of x-axis. This one is x-axis origin. This one is y-axis. vertical line. PT is tangent. Therefore, slope of tangent PT is equal to tan theta. You say that this value is m. M means slope of the tangent PT. Suppose here you can taking Q is neighborhood point of P. Very close to P. Just remember this point is P. Q is neighborhood point of P. Very close to P. The coordinate of Q is equal to x1 plus delta x or x comma y. Simply you say that x plus delta x comma y plus delta y. You say that these are delta x and delta y are small changes of x and y. Very close to P. P ಗೆ ಬಹಳ ಹತ್ರ ಇರುತ್ತೆ Q ಅನ್ನೋದು. But ನಾವು ಇಲ್ಲಿ ನೋಡಲಿಕ್ಕೆ you can taking P Q here. It's clear? Then draw the chord PQS. ಇದು chord. This chord PQS makes an angle pi to the positive direction of x-axis. ಇದು positive direction ಅಲ್ಲಿ. Then draw PL QM perpendicular to x-axis and PR perpendicular to QM. PR is perpendicular to QM. Then you get this RPQ is a triangle, right angle triangles PRQ. It's clear? Here PR is parallel to x-axis. This line makes angle pi to the positive direction of x-axis. Therefore, this angle, here you know that angles RPQ is equal to pi. This angle is also pi. Here coordinate of P is x comma y. Distance OL is equal to x, distance PL is equal to y. Coordinate of Q is x plus delta x comma y plus delta y. This distance OM is equal to x plus delta x. The distance QM is equal to y plus delta y. Then the distance LM is equal to QR, PR. What is PR? LM. LM can be written as OM minus OL. X coordinate x plus delta x minus x coordinate x. X cancels. This value is delta x. Similarly, the distance QR. QR is equal to QM, y coordinate y plus delta y minus RM. RM means PL, y. Y plus delta y minus y means this value is delta y. It is clear? Here you know that PRQ is a right angle triangles. Then you say that the value of tan psi, tan pi is equal to, either take psi or pi. Tan pi is equal to opposite sides PR divided by adjacent sides QR divided by PR. QR means delta y divided by delta x. It's clear? Here you know that geometrically tan theta, slope of the tangent M. Tan pi, the chord makes an angle pi to the positive direction of x-axis. Then the value of tan pi is exactly equal to delta y upon delta x, the incremental ratio. Suppose you can say that this Q tends to P. Q is coincides with P. This one is the curve. Here P ಇದೆ, ಇಲ್ಲಿ Q ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇದು chord ಆಯಿತು. Q ಏನಾದರೂ ಇಲ್ಲಿಗೆ ಬಂದರೆ this chord. This one is tangent. ಆಗ chord ಏನು ಬರುತ್ತೆ? ಹೀಗೆ ಬರುತ್ತೆ. Q ಇಲ್ಲಿ ಬಂತಂದರೆ chord like this. Q ಇಲ್ಲಿ ಬಂದಾಗ chord like this. Q ಇಲ್ಲಿ ಬಂತಂದರೆ the chord like this. Suppose Q tends to P. ಇದು ಸಡನ್ ಸ್ಲೋ ಆಗಿ ಚೇಂಜ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಪಾಯಿಂಟ್ಸ್ ಹೀಗೆ ಬಂದಾಗ ಇದು ಮೂವ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಸಪೋಸ್ Q tends to P, Q is coincides with P, then called QPS become a tangent PT. ಈ ಕಾರ್ಡು ಹೀಗೆ ಚೇಂಜ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಆ್ಯಂಗಲ್ ಯಾವಾಗ Q tends to P ಆದಾಗ, ದಿಸ್ S is coincides with T, ಇದನ್ನು ನಾವು ಹೇಳ್ಕೊ ಬಂದಾಗ ಹೀಗೆ ಬರುತ್ತೆ. ಇಟ್ ಈಸ್ ಎ ಟ್ಯಾಂಜೆಂಟ್. ಇಟ್ ಇಸ್ ಕ್ಲಿಯರ್? ಅಂದರೆ ಏನು? Q tends to P ಆದಾಗ this angle psi tends to theta. Then called QPS, it tends to tangent PT. ಇಷ್ಟೆಲ್ಲ ಆಗತ್ತೆ ಗೊತ್ತಿರಬೇಕು. ನಾವು ಕ್ಯೂ ಏನಾದರೂ ಪಿ ತಂದಾಗ ಆಗ ಏನಾಯಿತು, ದಿಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಚೇಂಜ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ದೆನ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಯು ಸೇ ದ್ಯಾಟ್ ಆಸ್ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಟೆನ್ಸ್ ಟು 0. It is clear? This curve like comes to here, 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 then delta x becomes 0. ಈ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಅನ್ನೋದು ಇದು ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ, ಇಲ್ಲಿಗೆ ಬರುತ್ತೆ, ಟ್ರಯಾಂಗಲ್ಸ್ ಹೀಗೆ ಆಗ್ತಾ ಬರುತ್ತೆ, ಹೀಗೆ ಬರುತ್ತೆ, ಹೀಗೆ ಬರುತ್ತೆ, ಇದು ಇಲ್ಲಿ ಕೋಯಿನ್ಸೈಡ್ ಆದಾಗ ದಿಸ್ ಡೆಲ್ಟಾ ಎಕ್ಸ್ ಬಿಕಮ್ ಎ 0. ಇಟ್ ಟೆನ್ಸ್ ಟು 0. ದ ಡಿಸ್ಟೆನ್ಸ್ ಈಸ್ ವೆರಿ ವೆರಿ ಲೆಸ್. ಅಂದರೆ ಏನು? ಇಟ್ ಮೀನ್ಸ್ here you know that the definition of derivative dy upon dx means, here you said that the limit of delta y upon delta x, the average rate of change of y with respect to x delta x tends to 0. It is clear? dy upon dx, you know that the definition of derivative is limit of delta y upon delta x as delta x tends to 0. andre enaitu the limit of what is delta y upon delta x? You know that delta y upon delta x means tan pi. As delta x tends to 0 means pi tends to theta, pi tends to theta. You know that its value is limit of tan pi as pi tends to theta is exactly equal to tan theta. What is meaning of tan theta? Slope of tangent. This one is slope of tangent at P to the curve y is equal to f of x. To the curve y is equal to f of x. What is the meaning? dy upon dx, slope of the tangent to the curve P, slope of the tangent to the curve y is equal to f of x at the point P. What is P here? X comma y means it is the arbitrary point, moving points on the curve. In domain of the functions, this point is moving. This one is called the locus of a point. ಎಲ್ಲಿ ಬೇಕಾದರೂ ಇರಬಹುದು. Here suppose here you can taking p x1 comma y1 ಅಂತ ಹೇಳಿದ್ರೆ slope of tangent, suppose you can say that tangent at P x1 comma y1 is a fixed point andre this one is the value of the derivatives at the point x1 comma y1 ಆಗಿರುತ್ತೆ. ಹಾಗೆ ಸ್ಲೋಪ್ ಆಫ್ ದ ಟ್ಯಾಂಜೆಂಟ್ p2 ಅಂತ ತಗೊಂಡ್ರೆ x2 comma y2 ಅಂದರೆ dy upon dx ವ್ಯಾಲ್ಯೂಸ್ at the point x2 comma y2 ಇಲ್ಲಿದೆ ಅಂದರೆ ಇಲ್ಲಿ ಟ್ಯಾಂಜೆಂಟ್ ಅನ್ನು ಹೇಳ್ತೀವಿ, ಅದರ ಸ್ಲೋಪ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ಡೆರಿವೇಟಿವ್ಸ್ at the point x2 comma y2. x3 ಅಂತ ಇಲ್ಲಿ ತಗೊಂಡ್ರೆ x3 comma y3 the slope of the tangent, the value of the derivatives at the point x3 comma y3. ಅಂದರೆ ಏನು ಮೀನಿಂಗ್ ಇದು? Suppose this function is continuous function, it is differentiable, means in each point you draw a unique tangent. ಪ್ರತಿಯೊಂದು ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲೂ ನಾವು ಟ್ಯಾಂಜೆಂಟ್ ಹಿಡಿಬಹುದು. Here dy upon dx is always unique. The values in a particular point, the value is always constant. Therefore you can say that the geometrical meaning of dy upon dx means you draw a tangent. This one is meaning in each point you draw a tangent. That tangent is unique tangent and the slope of the tangent is exactly equal to dy upon dx. You draw a unique tangent means this function is differentiable. Differentiable means this one is exist means in each point you draw a tangent. The geometrical meaning means in each point draw a tangent. In each point you draw a tangent, unique tangent, and its slope is dy upon dx. In the particular point, P is the arbitrary points. It means dy upon dx means the slope of the tangent at the point P. ಇದು geometrical meaning of dy upon dx. Suppose you say that the function is differentiable, you draw a unique tangent. The slope of the tangent is exactly equal to the value of the derivatives at that point. ಇದು geometrical meaning of dy upon dx. It's clear? Dy upon dx means the slope of a tangent to the curve at the point P. In arbitrary point, P means is the arbitrary point. This one is the geometrical meaning. Suppose the function is not differentiable, then not get the unique tangent. Athava suppose the curve is not continuous. Suppose continuous, usually you can draw a tangent, unique tangent. Suppose it's a fixed point, you not get the unique tangent, then you say that this function is not differentiable. Here draw the infinite tangent. But you draw the unique tangent, it is possible. The slope of the tangent is exactly equal to dy upon dx. This one is the geometrical meaning of dy upon dx. ಇದನ್ನು ಇಟ್ಟುಕೊಂಡು ನಾವು equation of tangent and equation of normal ಅನ್ನು ಬರೀತೀವಿ. Suppose given that y is equal to f of x. This is a real valued functions, continuous and differentiable. This function is, suppose you can say that this one is y is equal to f of x. P is the arbitrary point x1 comma y or fixed point x1 comma y1 is any point on the curve. Let us assume that P x1 comma y1 be any point on the curve. Then you say that this PT is tangent. This one is tangent. This PT is tangent. Draw the line perpendicular to the tangent and passing through the point P, Pn. This one is called the normal. This value is always passing through the point P perpendicular to the tangent. Pn is called the normal. This one is normal. It's clear. Then you know that by geometrical y is equal to f of x, continuous curve, it is differentiable, is the real valued function, no? Given curve P x1 comma y1 be any points on the curve. PT is tangent and Pn is normal. Pn is normal. Then you can say that dy upon dx is slope of tangent. Then you say that dy upon dx is called the slope of tangent to the curve. Slope of tangent to the curve. Therefore, you can say that the first one, slope of tangent at P x1 comma y1 is exactly equal to dy upon dx, the value at the point x1 comma y1. That one is the slope of tangent to the curve. Slope of tangent at the point P x1 comma y1, you say that this value is m. M means exactly value of the functions at the point x1 comma y1. Therefore, the second one, equation of tangent. PT is, it means it is a straight line passing through the point x1 comma y1 with the slope m. Therefore, you can say that y minus y1 is equal to dy upon dx values at the point x1 comma y1 into x minus x1. Y minus y1 is equal to m into x minus x1. The third one, slope of normal. Pn is equal to, here you know that Pn is perpendicular to PT. Suppose you can say that slope of normal Pn is at the point x1 comma y1. It means that value is minus 1 divided by m. It means minus 1 divided by dy upon dx values at the point x1 comma y1, that is m dash. It is clear. Therefore, the equation of normal Pn is y minus y1. This Pn is also passing through the point x1 comma y1 with slope is m dash. Slope and point forms y minus y1 is equal to minus 1 divided by dy upon dx values at the point x1 comma y1 into x minus x1. This one is slope of tangent, equation of tangent, slope of normal and equation of normal. And similarly, here find the conditions. using the derivative, just differentiating and find the values in a given point. Slope of tangent, take the reciprocal with opposite sign, slope of normal. Equation of line y minus y1 is equal to slope into x minus x1 in both the case. And the fifth one, you can say that suppose the curve is like this, the tangent is parallel to x-axis. This one is PT, this one is a tangent, this one is x-axis. Suppose the conditions tangent is parallel to x-axis. Any line is parallel to x-axis, slope is always 0. What is slope? dy upon dx at the point P, x1 comma y1 is equal to 0. The tangent is parallel to x-axis at the point P. It's clear? And sixth one, suppose the tangent is perpendicular to x-axis. This one is PT. It is perpendicular to x-axis. Conditions for perpendicular to x-axis or parallel to y-axis. Then you say that the slope is not defined. Slope means 1 divided by dy upon dx. Numerator is not equal to 0, denominator 0 is equal to not defined. You can say that slope is not defined means 1 divided by dy upon dx is equal to 0. Or you can say that the reciprocal, this value is equal to 0 means 1 divided by dy upon dx at the point x1 comma y1 is equal to 0, minus 1 by, you can say that. Or you can take this value is 1 divided by 0 means this value is not equal to 0, this value is equal to 0. It implies dx upon dy, the reciprocal at the point x1 comma y1 is equal to 0. This one is the conditions for the tangent is perpendicular to x-axis, the reciprocal equal to 0, or dy upon dx is not defined. You can say that dy upon dx at the point x1 comma y1 is not defined, or 1 divided by dy upon dx is equal to 0, or dx upon dy equal to 0, the tangent is perpendicular to the x-axis. And one more, here remember the seventh one, the two curves are cut at right angles. This one is y is equal to f of x and this one is y is equal to g of x. P is 0.2, PT1 first tangent to PT2 is the second tangent. This one is 90 degree. If two curves cut at right angle, two curves cut at right angles at P, remember, then m1 derivative of f of x with respect to x, you say that m1 at the point P, and slope of tangent at P, first curve, and derivative of g of x with respect to x and its values at the point P, say that m2, slope of tangent at P, second curve. Then m1 into m2 is always equal to minus 1. Then you say that two curves cut at right angle. Then the product of the slope at that point is equal to minus 1, the two curves cut at right angle. This one is the calculus methods. Without draw the graph, you can find the equation of tangent, slope of tangent, slope of normal, equation of normals, and conditions for the curve. The tangent is parallel to x-axis, tangent is perpendicular to x-axis, the two curves are cut at right angles. These are the applications in geometrical meaning of dy upon dx. Only the geometrical meaning dy upon dx means slope of tangent. With the help of that, you find the slope of tangent, equation of normal, slope of normals, conditions for the tangent is parallel to x-axis, conditions for the tangent is perpendicular to x-axis, the two curves, the angle between the two curves is also, and the two curves cut at right angles. Next we discuss the some problems. Examples. Find the slope of tangent. To the curve y is x square 1 comma 1. Simple questions. The next question is find the slope of tangent to the curve y is equal to x square at the point 1 comma 1. Very simple. Y is equal to x square, the given curve. Just differentiating with respect to x. Therefore, here you know that derivative of y with respect to x explicit form, so direct agi differentiate ಮಾಡ್ತೀವಿ. This value is 2x, so this one is slope of tangent in arbitrary point. It is clear. Therefore, slope of tangent at the point 1 comma 1 is, you know that dy upon dx values at the point 1 comma 1, you say that m, this value is 2 into 1, this value is equal to 2. 2 is the slope of tangent to the curve at the point 1 comma 1. It's clear. The similar way, find the slope of normal. Curve y is equal to x square or x cube plus x square plus 1 at the point 1 comma 3. Find the slope of normal to the curve y is equal to x cube plus x square plus 1 at the point 1 comma 3. ಆ 1 comma 3 ಅಲ್ಲಿ ನಾರ್ಮಲ್ ಹೇಳಿದಾಗ ಸ್ಲೋಪ್ ಆಫ್ ನಾರ್ಮಲ್ ಏನು ಬರುತ್ತೆ ಅಂತ. Very simple questions, 2 mark questions. The given curve y is equal to x cube plus x square plus 1. Just differentiating with respect to x. Therefore, you get dy upon dx. The notations, the derivative of y with respect to x. Derivative of sum is sum of that derivative. All are power function. Derivative of x cube 3x square plus derivative of x square 2x. Derivative of 1 is 1. You know that this one is the general slope of tangent in arbitrary point. But here find the slope of normal to the curve at the point 1 comma 1. Therefore, slope of normal at the point 1 comma 3 is minus 1 divided by dy upon dx values at the point 1 comma 3. Here write minus 1 divided by, put x equal to 1, 3 plus 2. 3 into 1 square is 1, 1 into 3 means 3, 2 into 1 means minus 1 divided by 5. This one is slope of normal to the curve. These are the examples. Solving some other problems in next class. Thank you.